We're gonna keep going on this jam today. We're working more and more on the working on the Godot Wild Jam, and doing a hexagonal match something game. Not sure even how many matches. I've had a bunch of ideas about what to do with that aspect of it. As far as matching is concerned, I have a few ideas. I have a pretty radical idea. I'm just not sure. I'm not sure how to play it out. However, regardless, vis-a-vis, ergo, let's look at what we got so far really quick. So we've got our little match 3 board, and we want to ignore those clicks that are outside the field. So okay, let me just explain this really quick. So we can hover over anything on the field and hit a button here and rotate, and right click and left click go in different directions. So this is our animation for rotation. I've got it set to take half a second. You can click really fast and it does some crazy stuff. Because the tweening and everything still... But that's sort of an accident. And it shouldn't actually do that. If there's no match, it's going to go back to where it was. Again, as far as a match is concerned, I'm not even sure what that is yet. And what happens when you match, I'm not even sure. I don't know. But this is where we're at to start with. So, looks like I've lost a bunch of frames here on my stream already. Let's check where we're streaming to. Mayhaps we lost our location. No, we are in Seattle. We aren't using the right graphics card. So let me see if I can change that. And let me check the activity, the task manager. As it were. Would that it were. Let's see, task manager is what they call it on Windows. And let's see, performance. And our GPU is doing nothing. Fantastic. Might have to restart the stream here. Give me a second. Video, stream, output. Let's see. Let's do a bandwidth test. Just for fun. Why not? Why not? Love you. Always have. Alright. Speed test. Is this going to reveal my IP for all to see? So we'll do it over here, offline, off to the side. Love you. Always have. Now it thinks we're in Fremont, California. Why does my ISP keep thinking I'm in different spots? I don't know. We know that the Ethernet cable is fine. So maybe before I do any streams, I should just test where it thinks I am. Okay, I'm going to restart the stream here in a second. I'm going to change my streaming server. All right. Now, I'm not sure Fremont... I can't remember if that's closer to Fremont, CA. Need to remember where that is. Maps. Union City, Newark. Oh, it's near the Bay. Okay, so I should say San Francisco. Give me a second here. Sit On the dock of the bay. Look at all those points just for existing. Bastille Day. Interesting. I was just watching something about the Battle of Bastille. I wonder if it was because of the date that it was recommended, but I don't think it was actually related to that at all. We've got a couple of drop frames, but we seem to be looking pretty good now. 15, 14. Okay, so the percentage is dropping. We seem to be okay now. Seems to only happen when I do this. Okay, let's go back over here. I'm gonna minimize that. Now we got the shared GPUs. Okay, so the Radeon is working. So our onboard graphics card is doing something. We do still have drop frames, but the percentage does seem to be decreasing. Still getting some drop frames. Anyways, we're going to call it good enough for now. Okay, so to do this animation stuff, I have an animation player to do the resizing portion of it, because it scales down and back up, and tweening that is not fun. And then I only use the tween for the position of the thing, which is happening here. So it's only 3 steps here. We do the interpolation for the movement. We start that tweening process, and then we also do the move animation for the pieces that we're moving. And that's happening in a for loop for each of the elements that we're rotating. And that seems to be working fine, so we're going to commit... Oops, we got to add stuff to commit. Alright, so movement, animation. I guess we'll call it piece movement animation. Yeah, so I hope everyone's doing well. I wish you well. And additional stuff. Those are always the best. Those kinds of commits. Okay. Now, back to what we were doing. I guess I could stand to lose some weight. And I could stand to lose some weight. Ha. Ha ha. Whoop. There we go. That seems good. What if we had the camera pointing down at me? So it's like I'm a cam girl. There we go. Now it's pointing down at me. Hey, boys. That's my cam girl. This appears to be an update for VS Code. I'm sure it will only make things better. Okay. So continuing on, we need to start figuring out the matching stuff for this, right? So what are we going to do here, guys? What are we going to do? Here's that. That's something to take a picture with? I don't know what that's about. Let's rotate this. There we go. Alright, we're all set. Get that hair back. There we go. Oh, I'm looking pretty good. Yeah. Looking pretty good. Oh, yeah. What was I saying? I don't know. I get to feel like a giant. Look at this. My wife got these miniature diet drinks for super cheap. So we could start working on matches. Matching is actually going to be relatively easy for this. Now, if we go back to the game itself, my plan for matching was going to be real simple. Now, here's another problem I'm dealing with. Now it's showing the highlighting of the center one, but it's not... Like, I can't actually choose the center one, you see? If I'm not on center, it's not happy. Or if I'm on center, it's happy. But if I'm not, it doesn't know what to do with the center one. Any other pieces, it's fine, except for the outer rim. So we need to reinforce some of the inherent logic here somehow. So we got to figure that out. Like if we're using a mouse, how do we tell the player that you can't go out here? It's not going to do anything. Not sure. And should the middle piece shrink too? I don't know. I do like if you watch, it does scoot through. It literally fits through each spot perfectly. Isn't that cool? Okay. Well, let's deal with matches. Here's... let me go back to what I was talking about. The way I was going to do matches is pretty straightforward. Along... If you consider the sides of the hexagon... if we were to follow each edge down this way, so, and down this way, basically all the edges where they meet. So we have an X going this way, right? And those are the two angles, really, because technically up and down are the same, you know, the same sides, right? And then just across. So really we're only matching on three sides. Or three angles, I should say. Sorry. So pretty straightforward, and then we just need those angles to iterate over. So match directions. Let's call it. We'll just build out a list of those directions. Now we're going to look at how do I move this over? Okay, moved it over to desktop 1. We have this beautiful website for hexagonal grid information. So if we want to travel down, yeah. We could go... There's a few ways to handle this. We know the width of our... the size of our puzzle. So right now we have 6. So if we know the size of our puzzle, we can pick a corner and start working our way across. Now, we need to... Sorry, just playing this out in my head. Now we have this rotation tool, or this, he's got a function here for rotate. Cube coordinates. We could do it with angles. So if we were to draw a line out from center to the edge here, and then to the edge here, and then to the edge here. Those are our points where we would want to... Really, these... Line. Okay, let's look at our hex grid code here, the hex cell stuff. And let's take a look at what we have in our outline. These ones we're not going to use. These are internal. Equal. Distance 2. Get neighbor. So we could use get neighbor. And dir. If we use get neighbor and we use the size of the and we get the 3 angles here, we can get all of the edges that we would want to work towards. And then till we reach 0. Is there something with distance 2? There's another way to consider it too. Okay, so if we use get line to cell, so if we combine, okay, so get neighbor will give us the outer cell. All right, let's let's start building out a function here. So Just thinking about how to approach this again. Check matches. And don't know what we're returning or doing or anything. But if we use get neighbor, so if we go hexcel var hexcel equals hexcel new, and we're going to go starting position of 0, 0, 0, which is just a vector 3, an empty one. And this is still, see, we don't even need this. We don't need to be too verbose there. So let's just print get neighbor where get neighbor is expecting is expecting a direction and an amount. Now, the direction for this way is -1, 1, 0. -1, 1, 0, which is the third. So if we were to say get neighbor 3, amount 6, and then we check matches here after we've built the ring, and it burns, burns, burns. Let's just see. Oh, it's going to return an object. And let's return the QRS. Returns it hexcel. Negative. Okay, so 0. No, it's wrong direction. Oh, it should be 2, not 3, because we're counting with 0. So -6, 6, 0 would be right, which would be this cell right here. And then we're going to start just going downwards as we work our way up towards this direction, which we can get with. So we've got. We'll have a bunch of neighbors. And we're gonna go look in. Hella decent. Where you been? Dropping about 20% of my frames right now for some reason. Hey, Frozen. I don't know if you saw the animation in real time, which I can show you real quick. Let me just show you. I like it. It's beautiful. Look at that. Whoop. We can go counterclockwise and we can go clockwise. And it kind of does this crazy thing if you tap it a bunch. The animations all fire at once. But it is correct in what it shows. 100 miles in the last 3 days. I think I'll probably do some more in the evening. That's awesome. Just be careful. Always look forward. So we're going to look up in this corner here too, which is 0, -1, 1. Which would be 0. And then we're going to look here, which would be 1, -1, 0, which would make it 1, -1, 0, which would be the final one here, 5. So 5. Those are our corners for one set of our matches. And I suppose to make this work for any size that we decide to make, we'll use the size constant here. Size. So if we change our puzzle size, that'll still work. So this gets us this corner here, and this corner here. We work towards, from this corner to this corner. Once we reach this corner, then we work towards that corner. So that's the conditional, in my mind, when I'm building this out. Automatically, always safe. I rock double red lights on my backside and super reflective jersey from Jackaroo. Oh, and I try to come home like a little kid when the streetlights come on. That's always a good idea because that's when the bad guys come out. That's when they spawn. Minecraft subconsciously teaching kids to, once the streetlights go off, to run inside. Or come on, I should say. Sorry. Once the sun sets, the streetlights come on. I'm trying to give my daughter the same freedoms that I had as a child. I realize nowadays we're sort of conditioned to fear everything and everyone, including incredibly safe areas that we live in. And it's actually dangerous as a parent to allow your child to be out on their own because you can get in trouble with the law for it, even though there's not really... It's all subjective and there's not... You know, the law doesn't say if child is X age old, they're not allowed to be out by themselves. It doesn't work like that. Although I kind of wish it would, so that it would just be easier. It's really based on like subjective whims of law enforcement and child protection systems and things like that. But as far as my individual freedom was concerned, when I was young, I distinctly remember walking home from school in 1st and 2nd grade, no problem. And nowadays, I think most parents would freak out about that. 1st grade would put me at 6 years old. So walking home by myself at 6, it was a couple of blocks. It was like 7 or 8 blocks, decent sized blocks. Braz. I'm not sure how to say your name. Pedro at the end there. Working on a project really similar. Oh, you're doing something with hexagons? Hexagons! Someday we'll just have drones that track our kids and they'll be able to be free-range kids again. I used to walk to town to get the bus from school when I was 8 or 9. Just Braz. Alright, I'll do that, Braz. Are you in Brazil?
Brazil. Round 1.
Do 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 do. Now the Brazil stage was do 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 do. Nice. Yeah, I watch. Oh, nice. That's quite a surname. I watch Felipe. I'm sure. I'm guessing you've seen him. He's another Godot streamer. Are you doing stuff in Godot, Braz? Wait, Brazil is your surname? Okay, so Braz, if you're using Godot, there's some code from a friend of the stream, Obsidian. Oh, nice. So he's done some work. He's developed this class called Hexcel. And yeah, I can show you what I'm doing. I'm making maybe a match 3. I'm not entirely sure, but it's going to be a matching game where you can rotate the hexagons around a point. Originally, the idea was to do it from the center and then outwards at each ring from center. But I got the suggestion that it might make sense to have something that you can move around and pick which ones you're going to rotate. And then I'm not exactly sure how we're going to do the matches. Initially, I'm going to do where they match at angles on the edges. So the three angles that they can match on in a hexagon. But I have some ideas about how they can kind of like, you know, like in this example here, if we were to, let me see if I can move these ones over. Here we go. So, like, let's say the system, let me move this one out of the way. Okay, so if we were to rotate this here, and let's say the match system is based off of 4 in a row, then if you rotate this, the matching should be all that are neighbors, right? So all of these would clear out. That seems cool to me. So that's what I think it should be like. It shouldn't be just angles. So one way I could do that is, man, there's a lot of stuff to consider with this, but I still do need to see if yeah, see, there's the question. There's the rub, man.